Hello, everyone. So from today, we're going to really discover the beauty of the periodic table. So today's topic is valence electron, Lewis dot structure, and the periodic table. Okay, so if you still remember, we said the number of protons is equal to the number of electrons for any neutral atom. When an element is neutral, has no charge, it has the same number of protons and the number of electrons. As we know, this number, this whole number in the periodic table in the symbol means the number of protons. For neon, this number 10 is neon. It contains 10 protons. Also, it tells us it also has 10 electrons. Okay, we also learned this electron arrangement from last week. Hopefully you still remember. I just quickly review it. We know that the first energy level of electron can only hold 2 electrons. The second energy level can hold 8 the maximum. The third energy level can hold 8 the maximum. Okay, there are totally 7 energy levels. We are only going to learn the first 3, and the rest of them are way complicated. We are not going to that deep. Okay, so it's 2, 8, 8. Okay, so one more thing is the valence electrons. What does it mean by valence electrons? We also learned it last week. It's a quick review for you. It's talking about the electrons in the most outer energy level. Okay, for example, this element has 2 electrons in the first energy level and the 4 electrons in the second energy level. And basically we say this is the typical element called carbon. Okay, it has totally 6 electrons, but we only call the 4 in the most outer energy level, we call them valence electrons. So carbon has 4 valence electrons. Okay, with that said, one more thing is the Lewis dot structure. For the first 3 pages of this slides, you already learned it. If you want to take notes, that's good. If you don't, it's okay because I hope you did it last week. If you didn't do it yet last week, please take notes. And for this one, I need you to take notes. Okay, it's Lewis dot structure. It's a gentleman called Mr. Lewis. He came up this method. We call it Lewis dot structure. Yeah, Lewis dot structure is a structure to represent the valence electrons. We're going to use dots to represent the valence electrons. What we do is first we write the element symbol and then draw dots around the element to represent the valence electrons. I'm going to give you a few examples, and you may pause here and write this note down. Okay, for example, hydrogen has 1 valence electron. We just write H to represent hydrogen and put a dot next to it. So this is called the Lewis dot structure of hydrogen. For carbon, it has 4 valence electrons, and we're going to just put C for carbon and the 4 dots around it. Normally, electrons want to spread out because they repel each other. And oxygen has 6 valence electrons. So we write a O to represent oxygen and put 6 dots around oxygen. Okay, and one more thing is electrons does want to stay together for 2 of them. So we call this an electron pair. So they pair up. So 2, 2, and these 2 would spread out to the 2 sides. It's symmetric, it's beautiful. Okay, that's how we draw it. Okay, now the task for you for today is I'm going to ask you to find a piece of A4 size paper. If you have a printer, that would be great. You can just print out the attached file in the pre-work folder. It's called the electron arrangements. You don't need to find a piece of A4 size paper. Okay, I'm assuming most of you don't have a printer at home. So we're going to do it on a piece of A4 size paper. Hold on. What's going on? And then you're going to draw the electron arrangements and Lewis dot structure for the first 20 elements. The paper in the pre-work folder look like this. Okay, if you have a printer, again, print this out. If you don't, we are going to do it by hand. Okay, I'm going to show you how to do this. I already did one example. You just copy that table on a piece of paper, and you're going to start to draw the first 20 elements in the periodic table. Okay, make sure there is a blank over here, just as similar as the periodic table. And then you leave a blank over here and label the group number on the top of your paper: group 1, group 2, save a place, and group 3, group 4, 5, 6, 7, and 8. And then I'm going to explain one by one how you do it. Okay. The hydrogen has one valence electrons. I mean, it basically have one electron. Okay. You just draw a circle, put one dot over here. This circle represents the energy level, and this one represents the electrons. Okay. And then for the Lewis dot structure, you're going to write H and put a dot over here. Okay, and then you can go to helium. Helium is right on the other side of the periodic table, the right side. Okay, helium has two electrons. You're going to draw a circle, put two dots, spread them out, and write He and two dots. This is the Lewis dot structure. This represents the electrons arrangement. Okay, and then you're going to do lithium. Lithium has three electrons, and it has one first energy level can only hold two. What you do is the third one is you put in the second energy level. Put a dot over there, and then you draw the Lewis dot structure, and the symbol is Li. And there's only one electron in the most outer energy level, so only has one valence electron. Put the dot, one dot. Okay, and the beryllium has two. I mean, it's four electrons. We're going to put two inside the first energy level and two go to the second energy level. And it only has two valence electrons, so you're going to put two dots. Okay, and then you're going to draw this one, two, three, four, five more until you go to neon. Okay, neon has 10 electrons, two in the first energy level, eight go to the second energy level, spread them out, and then it has eight valence electrons. You're going to put eight dots around neon, spread them out. Okay, and then you're going to go to sodium. Sodium, because this is full, right? This has eight valence electrons, and the maximum it can hold is eight. So sodium has 11 electrons. The first one has two, second one is eight. Two plus eight give you 10. So you have one more left. This one would go to the third energy level. Okay, and then you're going to do magnesium, aluminum, silicon, all the way down to argon. Argon is number 18. So you have 2, 8, 8. 2 plus 8 plus 8 give you 18. So argon has 8 valence electrons, draw 8 dots. Okay, I do need you to finish with potassium, number 19, and calcium, number 20. Okay, that would be your end. Okay, potassium has 19 electrons total. You're going to draw the first energy level has 2, second energy level has 8, third energy level has 8. So 2 plus 8 plus 8 give you 18. Potassium has 19, so you have 1 on the fourth energy level. Put 1 over here, and the valence electron of potassium is only 1. So you put 1 dot after potassium. Okay, and then you can finish at calcium. How are you going to figure out how many electrons they have? It's labeled in here, okay? And how are you going to figure out what element it is? It's also the symbol is over here, okay? So that's how you get the information from this page. You're going to, for example, for boron, number 5 is boron. You're going to write B over here, and you know it has 5. It's number 5, so it means have 5 electrons. Put 2 dots over here and 3 outside. And because it has 3 outside, so you're going to put 3 dots around B. Okay. Make sure to finish all of those elements. At the end, I'm going to ask you to observe if you can find any pattern on your drawing. Okay. What do the elements in the same group? The same group means the vertical column means group 1, group 2. Okay, what do they have in common? And then what do the element in the same period have in common? The same period means this horizontal side, period 1, period 2, period 3, and try to observe. And we're going to talk about it during the live class on Thursday. Okay, so once you finish this, take a picture and turn it in for 10 points. And those two questions, if you could figure out, that would be perfect. If you cannot, it's okay. We're going to talk about those on Thursday's live class. Thank you.